Now, one way you could plot your polar graphs is to use symmetry and zeros. Personally, I believe this is a lot of stuff to remember, and I think it's going to be a little tedious. So you could read through this if you like, and if you find something that may help you, and if you'd like to share it with others, then that would just be fantastic. But I believe that doing example 2, it says using symmetry to sketch a polar graph, we're going to do a little something like this. We're just going to sketch it, similar to how we did example 1. So let's make our table. We're going to have a table for our first and our second quadrants, and then we'll have another table for our third and our fourth values. Now obviously there must be something symmetrical about this, but if you look, it's a little bit different than our previous example, because before we had just the 4 sine of theta. Here we have a 2 plus 4 sine of theta. So that doesn't mean we're going to shift something up by 2. We're just going to plug in some values and find out what happens here. I mean, I don't know about you guys, but I'm kind of excited to see what happens, because I mean, we're changing the equation. We're still going to plug in the same values for theta. We're going to make our table, but man, I'm just really antsy about what this graph is going to look like. That's 2 pi over 3, by the way. In fact, let me just redraw it. My pen's getting a little crazy. 2 pi over 3, then we get a 3 pi over 4, then we have a 5 pi over 6. So let's plot these first. So if we plug a 0 in, 0, sine of 0. Sine of 0 is 0. So 4 times 0 is 0. 2 plus 0 is 2. I know you like how I'm doing all this mental math in my head. Hopefully you can do it as well. If you plug in a pi over 6, pi over 6. Well, the sine of pi over 6, we've talked about before, is going to be a 1/2. So if sine of pi over 6 is a 1/2, then that means 4 times 1/2 is 2. 2 plus 2 is 4. And then let's do a pi over 4. The sine of pi over 4 is radical 2 over 2. So if we take 4 times radical 2 over 2, that's a 2 radical 2. And a 2 radical 2 plus 2 gives us a 4.8. 4.8. And then let's do the sine of pi over 3. Well, that's a radical 3 over 2. So if we get a 2 times the radical 3 plus 2, that's going to give us a 5.5. 5.5. So we could plot these, but I'm going to wait to find out how big my circles need to be. So let's do pi over 2. Pi over 2, sine of pi over 2 is 1. 1 times 4 is 6. Sorry, 1 times 4 is 4. Plus 2 is 6. 2 pi over 3, well that's going to be a radical 3 over 2, positive, times 4 gives us a 2 radical 3. 2 radical 3 plus 2, that's going to be the same thing as over here. This is going to be a 5.5. Then you plug in 3 pi over 4, that's a pi over 2, times 4 is a 2 radical 2, plus 2, 4.8. And then we're probably going to get a 4 here. Excellent. You can notice some symmetry by your table, or some patterns by your table. Let's go with the third and the fourth quadrant now. So let's say at pi, then we have 7 pi over 6, and then 4 pi over 3. Then we have, what, a 5 pi over 3? No. I put these in the wrong order. We had a 5 pi over 4. Then 4 pi over 3. Then we go into the fourth quadrant, including our axis, so 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. So plug in a pi, sine of pi is 0, times 4 is 0, plus 2 is 2. Plug in a 7 pi over 6. 7 pi over 6. Now, 7 pi over 6 is going to be a negative 1/2 because we are in the third quadrant. Anything below your horizontal is going to be negative for your sign. So negative 1/2 of 4 is a negative 2. 2 minus 2 is 0. Plug in a 5 pi over 4. You get a negative radical 2 over 2. So 4 times negative radical 2 over 2 is going to give us just a 2 radical 2. So if you take 2 minus a 2 radical 2, then you are going to end up with a pretty little decimal that is negative. So how about a negative 0.8? And then 4 pi over 3. 4 pi over 3, that's going to be negative also. It's going to be negative radical 3 over 2. So negative radical 3 over 2 times 4 is a negative 2 radical 3. So you're going to have a 2 minus 2 radical 3. And when you plug these values in, you should end up getting a negative 1.5. So we get our negatives. Yay! 3 pi over 2. Sign is negative 1. So negative 1 times 4 is negative 4. 2 minus 4 is negative 2. So we're going to go in the 3 pi over 2 direction, a negative 2. Oh, that means we're actually going pi over 2. Plug in 5 pi over 3. It's going to be a negative radical 3 over 2. So that's going to end up being the same as your 4 pi over 3. Negative 1.5. And then this is going to be negative 0.8. And then this will be a 0, because 11 pi over 6 is a negative half. So you get a 0. So let's plot all of these points. 2, 0, in the direction of 0. You go 2. What's our largest number? Well, our largest number is 6. So let's go 1, 2, 3, 4, 5, 6. Let's make all these 1. So this will be a 1, 2, 3, 4, 5, 6, 7, 8 out here. So if we plot these, we're going to get a 2, 0. In the direction of 0, we go 2. So there's a point. In the direction of pi over 6, which is 30 degrees, we're going to go 4. And then at 45 degrees, we go 4.8, so it's going to be here. And then pi over 3, we're at 5.3. No, sorry, 5.5, which is here. That's pretty. At 90, we're at 6. So 6 is right here. And then your values start going back down. So this will be 5.5 at 120. Man, my pen is off. And it's aggravating me. You don't want to see me aggravated. At 3 pi over 4, you're at 4.8. So right here. Notice you do have some symmetry if you over your vertical axis. And then we're going to have one at 2. No, sorry, at 4. So 4. At this point, I cannot even see what I'm doing. That's 1, 2, 3, 4. Here's 4. And then, in the direction of pi, you go 2. So 1, 2. Then we have 0 pi over 6, 7 pi over 6. So that means we're going back to the origin because we can't go anywhere. So then we have negative 0.8 in the direction of 5 pi over 4. So 5 pi over 4 is 225 degrees, but we're going negative 0.8. So that means we're going to go back right here, in the opposite direction. And then 4 pi over 3, that's 240 degrees. We're going to go the opposite direction of 1.5. So we're actually going to be going 1.5 right here. And then we go negative 2. In the direction of 3 pi over 2. So 3 pi over 2, but we're actually going to go negative 2. So that means we're going the opposite direction. And then we have a negative 1.5. You'll notice we have a little bit of symmetry going on. And then we get back to 0. So if you were to plot this, plot these points in the, like a plane curve in the direction that from your theta value is getting bigger, we would start at 2, 0. Go up. And you make what looks to be somewhat of a circle. Up. Go down. Now this curves around, goes through 0, and it right here. Now probably it's going to go all the way over to here. So bam! If you were to draw more points, that's where the rest of it would be. This is a special kind of shape, and we will learn what kind of special shape that is very soon. I hate to spoil the surprise. So there's another example of how to sketch a polar graph using tables.